Hi, this is Ms. White. Our fourth solutions video is over solubility and solubility graphs. If you add spoonful after spoonful of salt to water at a given temperature, eventually no more salt will dissolve. This illustrates the fact that at a given temperature, there is a limit to the amount of solid that can be dissolved into a liquid solvent. When maximum solubility is reached, the molecules are returning to the solid form at the same rate at which they are going into solution. This is called solution equilibrium or dynamic equilibrium. The opposing processes of dissolution, which is dissolving, and crystallization of a solute occur at the same rate. A saturated solution is a solution that contains the maximum amount of solute for a given solvent at a given temperature. So the solubility of a solute is the amount of solute dissolved in a saturated solution. If more solute is added to a saturated solution, it falls to the bottom of the container and doesn't dissolve anymore. This is because solution equilibrium has been established at that point. An unsaturated solution is a solution that contains less solute than a saturated solution at a given temperature. More solute can still be dissolved under the same existing conditions. A supersaturated solution is a solution that contains more solute than it should be able to hold at a given temperature, so it is very unstable. When a saturated solution is cooled, the excess solute usually comes out of solution, leaving the new solution saturated at the lower temperature. Sometimes, though, upon cooling a saturated solution, the excess solute does not come out of solution and you form a supersaturated solution. It contains more solute than it should at that temperature. So it is unstable and the excess solute will come out of solution. This is called crystallization if the solution is disturbed. For example, agitation or adding a seed crystal would do that. This video shows what happens when a seed crystal is added to a supersaturated solution. And you can see the crystals forming right now. The table here shows the solubilities of some substances at various temperatures. Remember that the solubility is the amount of solute in a saturated solution. So question 1 says, why do the last 3 substances in the table decrease solubility as temperature increases? They are these 3 here, and they are gases, so we can see that their solubility decreases as temperature increases, and we know that this is true for gases. Number 2, describe a solution of 222 grams of silver nitrate dissolved in 100 grams of water at 20 degrees Celsius. I go to silver nitrate at 20 degrees Celsius, and I can see that I have 222 grams dissolved at that temperature. So that is a saturated solution. 45 grams of potassium chloride at 50 Celsius. So I go to 50 Celsius and potassium chloride, and I see that I have 42.6 grams dissolved when it is saturated. But I have 45 grams, so 45 is more than 42.6, so I have a supersaturated solution. 114 grams of lithium bromide at 100 Celsius. So I have 266 grams for a saturated solution. Since I have 214, it is less than 266. So I have an unsaturated solution. The information on the previous table can also be represented on a graph, where the y-axis is the solubility in 100 milliliters of water. It is quite common to express solubility per 100 milliliters of water. On the x-axis is the temperature of the solution. And we can see that as the temperature increases, the solubility of all these substances increases, as shown by the curves all going up. Cesium sulfate over here is an exception. These are all ionic compounds, and we know that solubility of solids increases as temperature increases. This over here is quite useful. Since liquid water has a density of 1 gram per milliliter, and we also know that 100 milliliters is equivalent to 100 cubic centimeters, then 100 milliliters of water is equivalent to 100 grams of water, which is equivalent to 100 cubic centimeters of water. So this here could represent 100 grams, 100 cubic centimeters, or 100 milliliters. They are all interchangeable. On a solubility curve, a saturated solution contains a mass of solute that lies on the solubility curve. An unsaturated solution will contain a mass of solute that is below the solubility curve, and a supersaturated solution will contain a mass of solute that lies above the solubility curve. The solubility curves on this graph here are for gases, and we can see that the solubility of gases decreases, so solubility decreases as temperature increases. Is this a direct or inverse relationship? It's inverse, because they do the opposite. We are going to work out 10 examples. Let's start with number 1. Which solute is most soluble when the water is 10 degrees Celsius? So I go to 10 degrees Celsius over here, and I see that sodium nitrate will dissolve the most. Solute has the lowest solubility at 60 Celsius. So I go to 60 degrees Celsius, and I see that cesium sulfate has the least amount of solute dissolved at that temperature. How much potassium chloride dissolves in 100 milliliters of water, that is 45 degrees Celsius? So I check that my amount of water matches the amount that is given for the graph, and it does. So then I go to 45 degrees Celsius, and it is here, and I find how much potassium chloride will dissolve at that temperature. So I go to the potassium chloride curve, and I can see that it's about 41 grams. Number 4, how much potassium nitrate will dissolve in 500 milliliters of water at 45 Celsius again? So I go to 45 Celsius, and this time I go all the way up to potassium nitrate, and I can see that I have about 75 grams, but this is in 100 milliliters of water. So I have 75 grams that dissolves in 100 milliliters of water. So I do a proportion, and I say 75 over 100 is equal to x over 500. And I get that x is 375 grams. If you stir 50 grams of potassium chlorate in 100 grams of water, that is 70 Celsius, will all of it dissolve? So I again check my amount of water. It does match. Remember that grams and milliliters are interchangeable. So then I go to 70 Celsius, and I go to potassium chlorate. And that is equivalent to 30 grams that will dissolve. So at 70 Celsius, 30 grams of KClO3 will dissolve. So if I have 50 grams, I have too much, and not all of it will dissolve. So if I do 50 minus 30, 20 grams will not dissolve. Number 6, how many grams of sodium chloride will dissolve in 32 milliliters of water at 90 degrees Celsius? So this time I check my amount again. I only have 32 milliliters of water. So this doesn't match my graph. So on my graph, I can find out how much will dissolve in 100 milliliters. So I go do that. At 90 Celsius, I go to sodium chloride, and I have 40 grams will dissolve. So 40 grams in 100 milliliters of water. And again, I do a proportion. So I say 40 grams over 100 is equivalent to x in 32 milliliters of water. And I get x equals 12.8 grams, which will dissolve. Number 7, if we stir 180 grams of sodium nitrate in 200 cubic centimeters of water, that is 10 degrees Celsius, how many grams won't dissolve? So again, I check my amount of water. It is 200 cubic centimeters, and I only have 100 here. Again, cubic centimeters and milliliters are interchangeable. So I can check from my graph how much will dissolve in 100 cubic centimeters. So I go to 10 degrees Celsius, and I go to sodium nitrate, and I see that 80 grams will dissolve. So I have 80 grams in 100 cubic centimeters of water. So I need to find out how much would dissolve in 200. So I do my proportion, 80 over 100 equals x over 200. So x equals, of course, 160 grams. And I'm not finished. It's asking me how many will not dissolve. So 160 will dissolve. So if I have 180, I will do 180 minus 160, and I get 20 grams will not dissolve. 3 more. If you have 80 grams of potassium nitrate in 100 milliliters of water at 40 degrees Celsius, is this unsaturated, saturated, or supersaturated? So I have to plot the point, and I check that I have 100 milliliters of water to match my graph. So then I can read straight from my graph. So I go to 40 degrees Celsius and 80 grams, and I plot that point. Then I look at my potassium nitrate curve. It's over here. So that point is above the curve. So we are supersaturated. Number 9, if you have 50 grams of water as a solvent, how many grams of solid sodium chloride would you need to saturate 100 degrees Celsius water? So I have 50 grams of water. It does not match my graph. So from my graph, I will know how much will dissolve in 100 grams of water, because grams and milliliters are interchangeable. So I go to 100 Celsius and sodium chloride, and I see that 40 grams will dissolve. So 40 grams will dissolve in 100 grams of water. So I do my proportion, 40 will dissolve in 100. So how much will dissolve in 50? And I get x equals 20. So 20 grams will dissolve. Saturated solution of potassium chloride in 100 milliliters of water at 90 degrees Celsius is cooled to 10 degrees Celsius. How many grams of potassium chloride will crystallize out? So I go to 90 degrees Celsius and I find out how much of potassium chloride is dissolved. And we have about 55 grams. So at 90 degrees Celsius, I have 55 grams. Then I go to 10 degrees Celsius, and I have 30 grams that is dissolved. So how much will crystallize out? All I have to do is subtract those two. So I get 25 grams of potassium chloride that will crystallize out. This concludes video 4. You should have taken good notes. Rewatch the video as many times as you need and come to class with your questions.